Welcome back. We will now begin the second lesson of Section 3 in Unit 5, covering the concept of subtracting mixed numbers. In the first video of Lesson 1, we will explore the subtraction of mixed numbers concretely or pictorially. We will once again use the same models that we have used throughout this unit and examine the same two types of questions previously considered when modeling. Given a visual, determine the answer to a given subtraction calculation, and given the calculation, represent it by modeling to determine the difference. And we must not forget about our answers being in simplest form. Let's have a look at our fraction circles or rectangles. In our first example, we're going to use the model to determine the difference. Well, first we need the actual subtraction calculation being represented here. So on the left-hand side of my subtraction sign, where my minuend is located, I have two wholes and 3/4 of another. Right-hand side of my subtraction sign, where I have my subtrahend, I have one whole and 5/8 of another. So we're subtracting here 2 3/4 and 1 5/8. So let's see how we're going to do this. We discussed previously the idea of subtraction being the same as takeaway. And also when we looked at this particular model, we considered the overlap region. So I want to overlap my subtrahend with my minuend. Well, I see a hole here and a hole here, so I should be able to overlap those. And then I have more shaded in this particular partially shaded hole than what I have right here. So I should be able to take away this from my partially shaded hole right here. So I can overlap those. So let's do the overlap. There we go. And we need to remove the overlap region. So if we take that away, well, what are we left with? Well, I have one complete hole, one complete circle left shaded, and 1 out of 8 pieces in the second hole. So our conclusion is that 2 3/4 subtract 1 5/8 gives us 1 1/8, and that's simplest form. In our second example, we're going to use fraction rectangles this time to model and calculate 3 1/2 subtract 1 3/4. We want a visual for 3 1/2. So 3 shaded rectangles and half of another. For the 1 3/4, 1 fully shaded rectangle and 3/4 of another. We think about the takeaway idea or the overlap idea, and we should have no trouble overlapping one hole from our subtrahend with one hole from our minuend. That's easy enough done. There we go. Now we would probably now want to think, well, what if we overlap this partially shaded hole from our subtrahend with this partially shaded hole from our minuend? Well, what I should do first is take the half piece and divide it into fourths. So I'm working with an equal number of sections. So of course a half would become 2/4. If I was to try now to overlap those, I run into trouble, and it's not allowed, because I have 3 shaded in my subtrahend partially shaded hole and only 2 here. I can't take 3 from 2. So what do we do? Well, what we're going to do is take another hole, divide it into 4 equal sections, and then I can overlap this partially shaded hole from my subtrahend with a hole that's been divided into 4 equal sections in my minuend. So now we have an overlap region here and here. We take those away and we look at what we're left with. Now I have a partially shaded hole in my minuend and another partially shaded hole in my minuend. We're going to combine those. So I'm going to take that 1/4, pop it over with the 2/4. We now have one hole and 3/4 of another remaining. Pattern blocks. Use the model to determine the difference. In the minuend, on the left-hand side of my subtraction sign, I have one whole, one hexagon, and two rhombi, 2/3. We are subtracting. We have one triangle. So this is just 1/6, a proper fraction. We want to do the overlap thing. So I'm going to take that triangle and pop it over with the two rhombi and overlap. We want to remove that overlap region. Take it away. And what it actually leaves me with then is the shape for a trapezoid. So we get an answer of one hexagon and a trapezoid is a half. In example 2, we're going to use our pattern blocks to calculate 2 1/2, subtract 1 5/6. Let's give a picture for 2 1/2, 2 hexagons, and a trapezoid. A picture for 1 5/6, 1 hexagon, and 5 triangles to represent the 5, 6. Overlap. Well, I can certainly take this hexagon and overlap it with one from my minuend. That's no problem. Now, again, I'm probably going to try and take this partially shaded hexagon and overlap it with my trapezoid. If I split my trapezoid into 3 triangles, and if I was then to try and overlap, no way. We run into that issue again. I have more triangles in this partially shaded hexagon than I have in the partially shaded hexagon from the minuend. So I cannot overlap them. So what do? We go back to my other whole hexagon in my minuend. And I put that into 6 equal triangles. Then I can overlap. There we go. Now we can remove the 2 overlap regions. Take them away. And what are we left with? I have 2 partially covered hexagons. I have 1 triangle here, and I have 3 triangles here. Let's put them into 1 hexagon. So I move that 1 over. So we have 4 triangles, which we know represents 4, 6. And 4, 6 can reduce. It makes perfect sense with our pattern blocks because for every 2 triangles, we can create a rhombus. Each rhombus is 1/3, so we have 2 rhombi, giving us 2/3. Final answer. And last, but certainly not least, let's have a look at our fraction strips and the number line. So here's our model. We need to figure out the subtraction calculation. For my minuend, I'm going to look at the bottom set of strips here, where I have a 1, another whole, and then 2 1/5. So 2 wholes, and the 2 1/5 will give me 2/5. What am I subtracting? Well, there, I'm going to look at my top set of strips, where I have 1 whole and 3 1/10, which will give me 1 3/10. So my minuend is 2 2/5. My subtrahend is 1 3/10. Let's take it away. This is what we're left with. This will give us our answer. Well, what I should probably do first is focus on how my number line is divided up here. And if you count the equal spaces in between each hole, you will get 10. So every little tick is a 10th. So this place right here on my number line where we end off will represent 1 1/10. And that cannot reduce. In our second example, we're going to use our number line and our fraction strips to calculate 2 3/4, subtract 2 1/8. Let's first of all have a look at our denominators here. Because when we put down our number line, we want to know what to divide our number line into, what numbers of equal sections between the wholes. Well, my LCD for 4 and 8 is 8, so I will have 8 sections in between each hole. There we go, all labeled. Now we're going to place down 2 3/4, so 2 whole fraction strips and 3 1/4 strips, and we're going to take away 2 wholes and a 1/8 fraction strip. Let's highlight, let's take it away, and what are we left with? It starts at 0, and it ends at 5/8. So 5 1/8 strips will cover up that area beautifully. Our answer to this particular subtraction calculation is 5/8, and that cannot reduce. And as we did before when subtracting fractions, let's take a second look at fraction strips on the number line. So here's our picture. We want the calculation. The first thing we're going to do here is have a close look at our number line and see what it's been divided up into. So in between each hole, I have 1, 2, 3, 4, 5, 6 equal sections. So every tick here is a sixth. So I go to where my fraction strips end off right here. That will be at 3 holes and 1/6. That gives me my minuend. That's the first mixed number I'm dealing with. And what am I subtracting? What am I taking away? Well, for that, I look at my fraction strips that have been laid down. And I have 2 holes, so I'm subtracting 2 holes, and I have 2 1/3 strips, so that's 2/3. The question is, well, where do we end up when we take those away from 3 1/6? Well, I end up right here, which coincides with 3/6. But in this case, we can't leave our answer as 3/6 because that can reduce to 1/2. Example 2, we're going to model 3 1/4, take away 1 1/2, and we're going to calculate the difference. I need to decide on my number line. I look at my denominators. My denominators will tell me the equal sections that I'm going to have between my holes. The LCD is 4, so there we go. So in between each hole, it has been split into 4 equal sections. I have 3 1/4. That's where I start. So I go right up to here. 3 1/4. What am I taking away? My subtrahend is 1 1/2. Going back 1 1/2. Where do I end up? 1 3/4. So our difference, when we subtract 1 1/2 from 3 1/4, it's equal to 1 3/4, simplest form. And now I'd like you to proceed to the next video in this lesson.